thanks for joining this session of Data in Charge. We're going to talk about what we call hybrid AI and what it entails in an enterprise environment. So I'm Dheeraj Remella. I'm the Field CTO at Volt. Had the good fortune to work with several of our customers, and hopefully this session will be very useful. So in this session, what we're going to talk about is why does this concept of hybrid AI matter? And what are the challenges of intertwining probabilistic and deterministic together? And how does that hybrid AI architecture look like? We'll look at a couple of industry examples and a reference flow architecture. And how do we get started with Volt and hybrid AI? So what is the core challenge? Data is streaming. Real-time events are now off late, primarily streaming data. It could be any of the industries, right? So IIoT, telecom, finance, energy, utility, smart X, whatever you think of it. The event streams are increasing. This data, when fed into LLMs, it gives you an intelligent probabilism, but it does lack guaranteed determinism, meaning every time you ask the question with the same data, the answer should be the same and the actions should be the same. And this is a challenge of this problem. So what is hybrid AI? Within hybrid AI, we look at agentic AI pipelines, combining the reasoning and planning and the intelligence, the raw intelligence that LLMs actually bring to the table, and combining that with low latency deterministic logic expressed and exposed to agents through tools. It could be MCP tools and any other upcoming standards like UTCP can even participate in that. But what does this do is it brings deterministic intelligence into the planning within milliseconds. So you're not just giving the data to the LLM and hopefully it comes up with the right expression of the intelligence, but rather be able to codify a deterministic intelligence layer and incorporate that into your LLM's plan. That is this mixture of determinism and probabilism is what we call as hybrid AI. Now, there are certain forces that, we already saw that the streaming data, right? So then add to that stream processing, then you have agentic AI. The LLMs are more or less better serving enterprises in the agentic AI space and perhaps in the future in the physical AI space. That just chatbots, right? So now add that and the need for deterministic transactional logic to ensure that you have explainability end-to-end. All these forces are coming together to warrant something of the type of a hybrid AI. Now, LLMs give you that probabilism. Volt active data, in this case, gives you that deterministic layer. So it's not just, Volt is not just a database. It doesn't just serve the data. It could serve just the data, but the more interesting way of using Volt is to apply the business logic, machine learning model inferencing, all of that into one umbrella inside Volt, and be able to invoke that as a singular transactional construct. So it's all or nothing, and be able to incorporate that through MCP tools into your LLM agentic AI framework, right? So the balance between LLM proposing a plan and orchestration versus Volt transactions validating and executing the actual business logic. When you combine them, you have a good balance scenario of bringing probabilism and determinism together in a meaningful way. Okay. Now, the pattern itself, it goes across industries, like wherever there's data, then you can actually run it through a multi-agent scenario. And the agentic AI essentially takes this data sources like events, metrics, logs, context data, or even telemetry in industrial IoT kind of scenarios, and bring that all together and detect patterns, create reasoning, select appropriate tools, and draft plans for orchestrating between people. Now, these tools will go and just fetch the data from the real-time stores, Or you could actually go to something intelligent like bulk active data, wherein you can actually have safety gates, policy checks, and atomic multi-mutation updates all together in a deterministic manner. And you can even run machine learning model inferencing for models where you actually have these models as deterministic models. And then you have the downstream actors that based on the decisions taken inside Vault and orchestrated by the agents, you can invoke actions to interact with the real world and create action items. Okay. One of the examples could be telecom space, the RAN signals and counters, any of these metrics that the RAN equipment actually emit could be brought into an agentic AI environment, along with your network quality of service, violations, spikes, and some edge data from multi-access edge computing nodes. All of this could actually come into the agentic AI, and now at this layer, you would actually apply probabilistic rules that the agents actually learn, the LLM, the fine-tuned LLM, learn from your environment, your enterprise, and be able to evaluate options as to should I throttle the flow or migrate the sessions to a different part of the network to provide availability, et cetera, et cetera. And so once you actually make this determination, then you turn around and actually choose a tool and invoke that tool. In this tool, the adjust slice allocation from Vault would be the most appropriate tool and be able to take that corrective action, check the bandwidth, min-max for per network slice, don't overcommit a slice more than what's available in the overall bandwidth, but be able to apply all these changes atomically in under 10 milliseconds. And the actors themselves are downstream to near real-time rig or traffic steering, UPF policy engine, charging. These are all like possible actors, or even an orchestrated set of actors that all need to do something in the final outcome post the decision. Okay. Now, within financial services, you can have transaction streams from point of service. It could be e-commerce, wallets, any of the multiple angles of consumption of commerce, but actually generate signals. And on top of that, you would have merchant risk signals that are getting updated in a real-time manner based on like how many returns, how many times they've actually filed and participated in fraudulent transactions, reconciliation. All of that could actually increase the merchant risk signal. And these signals could be married along with the transactional data and the device information, location information. All of these would come in, and the agent now interprets the anomaly patterns and creates the hypothesis. Okay, this is the possible type of fraud that is actually happening right now, and then invoke a Vault transaction through MCP tools for fraud check. Now, Vault itself can actually take a deterministic fraud check model and then run it, or fraud scoring model, and run it against the incoming event in the context of the near past information that's already involved, and be able to say, okay, this transaction is good, you can authorize it, or you have to decline it. It's in the gray area. Let's actually kick off a two-factor authentication. Now, all of these can be done inside an atomic write without any race conditions. Now, once you take the decision, you push it down to a ledgering layer or audit trail. So if the end customer calls the call center back and say like, hey, you declined this, it's not the right thing to do, then you have an audit trail as to why it was done. And now once that's done, once those decisions are done, then you can invoke actions like, hey, I want to send a decline signal to the card network or request an authentication code, authorization code from the fraud network, and send out a fraud orchestration engine to kick off the reconciliation process if it's already happened, or be able to prevent it even, and thus SMS the customer to say, hey, there is a fraudulent attempt on your credit card, so we declined it. And now, whatever these decisions are, you would send these downstream into the machine learning model, retraining queues. So you could actually take something like an Apache Iceberg and run the delta data and take that into retraining cycles. Now, what's the common pattern, right? Like, so you have sources of data that's pushing streams of data, and then you have a stream processor. The stream processor engages with an agentic AI orchestration and planning layer, and this layer invokes tools, and some of those tools could be both transactional API or stored procedures, as the case may be, to take deterministic decisions. And once these decisions are taken, you invoke action in the real world in the downstream system. Yes, this is the source to an intelligent event data response journey that would actually look like in this reference. Yeah. Now, key takeaway, what is the digestion of this whole session? It's pure LLMs are probabilistic, prone for hallucinations, perhaps make even like incorrect, inadvertently maybe, but incorrect decisions. So it's not enough when you have to act in real time at a high scale, low latency, high integrity kind of decisions. And this is where hybrid AI becomes a really viable path to incorporate that deterministic execution logic into your probabilistic reasoning. So this is what we call as hybrid AI. The pattern itself is clear across industries. The deterministic guardrails are extremely important because if you don't have them, there's a chance that you would have done half of it correctly and half of it is so Volt provides that low latency transactional backbone that operationalizes this hybrid AI concept. So you can play with Volt. We have a developer edition. We have also a Volt for streaming decisions edition that you can come in and give trials, or you can just reach out to me, DM me on LinkedIn, and we can take the dialogue to see if this approach is even suitable for you and if Volt can actually help you. Looking forward to hearing from you guys and having a dialogue. All right. Thank you so much.